we're talking more about complex numbers, and remember we have I is the square root of -1, and our general form of complex number is a plus ib. All right. One thing I didn't show you that I should is some more definitions and whatever. So generally we let z be our complex number, z and w, and there's this notation. Z bar is called the complex conjugate, and it's just a minus ib. Basically, you change the minus, or you change the whatever's in the middle here. So if you have 4 plus 5i, if this is z, z bar, which is the complex conjugate, is 4 minus 5i. Sometimes this is the notation. They'll put a little star there. Just whatever the context of your book. So suppose we're multiplying complex numbers together. What's 5 plus I times, I don't know, 2 minus 2i? And incidentally, I'm just making these things up. You have to FOIL these out. So here is 10 plus I times 2, but I'm going to write that as 2i just because I'm used to it. What else do we got here? This is going to be minus 10i. And then here, minus 2i squared. Now we need to combine some things together, right? We have single i's here, have a single power, so this is going to be 10 minus 8i minus 2i squared. But if I is the square root of -1, I squared is -1, right? So this is 2 times -1, but this is minus, let me be more clear. So this is 10 minus 8i minus 2 times -1. Two negatives in a row cancel each other out. This is going to be 12 minus 8i. Once again, you guys are supposed to know this, or hopefully you do. What's the importance of the complex conjugates? They're very important because here's the deal. Z times z bar is going to be equal to a squared plus b squared, whatever a and b are. And I think I'm going to show you that right now. So suppose actually we'll just do it for real. What's a plus ib times a minus ib? I'll FOIL it out. Here is a squared. Then it's going to be minus abi, and this I'm putting these in a way that's easy to see. A times minus ib, you could write it as minus abi, iba, bia, whatever. This is just standard. And then it is going to be this times this. This is going to be plus abi, and then it's going to be minus I squared b. Okay, and right away you could be going, why is this I squared in front of the b here? I'll show you why in a second. It's just to make things look easier to look at. These are all correct. A plus ib or a plus bi. This is standard in general. This is fine as well. So here, minus abi plus abi, these cancel out. So we have a squared minus I squared b squared. This is why I brought the I squared up front. I squared is so this is going to be a squared minus I squared is -1. This is -1 times b squared. This is a squared plus b squared. So this is really pretty handy. You probably remember using this most when you were trying to do this. What is 1 over 1 minus I? They'd say write this in standard form, and this is what you do. You multiply the bottom by the conjugate. This is 1 plus I. Top by the conjugate, 1 plus I. Why? Because here is 1, a plus ib times a minus ib is a squared plus b squared. In this case, a is 1 and b is 1, so this is just multiplying the 1 here. This is 1 plus I divided by 1 plus 1 is 2. This is 1 half plus I over 2. This is getting a complex number in its proper form. We like them to look like this. But now, I want to introduce some more notation. The modulus of z. And this is going to be, this is z times z bar square root. Okay. So what is this? This is going to be, well, let's take a look at it. We know that z times z bar is a squared plus b squared. So this is the square root of a squared plus b squared. What is the modulus of z? Well, so remember, we can't say that I is positive or negative. Is I greater than 1? Is I less than 1? How do we measure distance in the complex plane? And the way that we do it is by taking the modulus, or the square root of the modulus. Let me see about your termination. Now, okay, so it's the absolute. This looks like absolute value. It's called absolute value or modulus. So this is what's going on here. 1, 2, 3, 4, 5. 1, 2, 3, 4. I'll do. Let's do 2 plus 3i, and I just made this up. What's going on with this? Here is 2, 1, 2, 3. Okay, here's 2 plus 3i. So if this is z, this is our complex number. What is this? The modulus of z. It's going to be 2 plus 3i times 2 minus 3i square root. This is just by definition. This is, after we FOIL this out, and we know this, I just proved this the last tape. This is, here a is going to be 2 and b is going to be 3. So this is 2 squared plus 3 squared square root. What is this on a good day? This is 4 and 9. This is the square root of 13. What's the relationship? What is that? Why would anybody care? Well, I'll show you something that's absolutely fabulous. That is the distance from here to here. This, the radius right here, or just coming out from the center of the circle, what is that? Well, this is going to be, this is 2, here's a right triangle, this is 3, this is 2 squared plus 3 squared, square root. That's pretty nifty. What just happened here? This can be thought of as a vector in the plane. And a vector is something that has magnitude and direction. Let me show you something else that's pretty neat here too. This is making some angle. Let's call it alpha. What angle is alpha? Well, actually, because you guys have been such great trigonometry students, you know exactly how to figure that out. Alpha is going to equal arctangent of what? 3 over 2. Because we know that tangent of angle alpha is equal to 3 over 2. That means that the arctangent of 3 over 2 is equal to alpha. Why is this important? Well, assuming, so I'm going to have to get my calculator to get this number, and we are going to load in a new tape, but all kinds of information just became opened up to us here. And I guess I'll let them load in another one, and we'll see you in a minute. So, welcome back to